Okay, this is video 35. Grab me a cup of coffee here. It looks like I'm recording, so I better quit worrying about coffee and worry about recording, right? All right, gang, this is video 35. We're going to look at including categorical predictors in a multiple regression model. And, it's a pretty straightforward approach, especially if we have a dichotomous variable. Dichotomous just means we have a categorical predictor with two groups. Gender would be the classic case of a categorical variable that's dichotomous. When we get into categorical variables that are not dichotomous, they're a little tougher, and they require a contrast coding. And I'm going to show you guys I guess probably the simplest and I think the most common, which is called creating dummy variables. So, let's get to it. So again, first thing I want to do is I want to illustrate, so the first model I'm going to run is I want to predict read from LSS, IQ, and I'm going to be using the same data set that we did before, EST, but this time I want to include gender. So gender is dichotomous, obviously, so this is going to give you the illustration of those calculations. The guys on my desktop, you can see that I have IQ read over here. So I'm going to need to get into R and open that up. So the first thing I need to do is set my working directory. And I need next thing I'll need to do is go get my data. And what I'll do, I'll have this data set uploaded on Blackboard. So, if you don't have it opened in R, it would probably be something you want to do. Guys, the graphing calculator, they work fine to set up matrices, but they do have limitation on how many elements you can put in. Sometimes we're going to run into extremely large data sets where it would be completely crazy and drive us all insane if we had to enter those in a graphing calculator. This is kind of a small data set here, but nevertheless I wouldn't want to have to try to put this stuff in the graphing calculator, and you're going to find that using R for this is not that bad at all. So guys, I want to read my CSV file, and I call that IQ read.csv. Now the next thing I want to do is I want to attach my data. And the next thing I want to do, which I found a little trick here, is we'll do what's called data frame of our data. It makes our variables easier to puts the variables easy. It makes it easier to put, well, easy for you to say, yeah. It makes it easier to put our variables in our matrix. So gang, the first thing I'd want to do here is, I want to look at gender. And you can see that I have levels of M's and F's. Well, the first thing I want to do here is I want to change that over to zeros and ones. And it's not hard to do that, but there is a little trick. So what we'll do here is we're going to do, I'm going to just call this gen recode. And what I do to do that is go as integer gender. Now don't hit enter just yet, because what that's going to do, the default in R, when we take a categorical variable, in this case, which is given as a string in M's and F's, we're going to change these over to an integer. By default, we're going to have ones and twos. And I'll tell you what, let me just illustrate that for you. And you know, that's fine. We could work the model that way, but you know, if you deal with models over and over and over, you're going to see that dealing with zeros and ones are better. So what I want to do here is I want to set a gen code as integer, but I want to subtract 1. So I want my males to be ones and my females to be 0. Now, guys, if I do gen recode, you'll see I have everything in terms of zeros and ones. So I'm ready to run some analysis. But the first thing I need to do is I need to see if gender is a factor. Now, this can get you in big trouble if you're running an ANOVA, if you're running a logistic regression. So the easiest way to do that is just do the function isFactor gen recode. Well, it's not. Well, guess what? We need to make gen recode a factor and not just a number. When we give a categorical variable placeholders of 0 and 1, it sees that, it being R, sees that as numbers. But we don't want numbers, we want placeholders, we want factors. So what I would do is I would do set factor. No, you don't do that. You just do factor gen recode. And now you'll see if I do is gen recode a factor, it'll say true. Now that's not going to matter at all in the calculations of our matrices, but I'm thinking it probably will. I'm not familiar enough with R to know if there is going to be a difference, but I know it would make a tremendous difference in other statistical software packages. So gang, what I want to do now is I want to create my design matrix X. But first thing I need to do is set up the column of ones. So I could do repeat integer, and I need ones to occur 30 times. I always like to test it out just to make sure it's right. So gang, I'm going to do capital X here, and I'm going to set up my matrix. I'm going to bind things with the C function. First thing I need is my column of ones. Next thing I need are my LSS. Next thing I need are my IQs. Next are EST. And finally I need my gen recode. Need to tell how many rows? Well, clearly I need 30. Number of columns are always going to be the number of predictors plus 1 to account for the column of ones. So in this case we're going to need 5 columns. Now we didn't enter our data by row, we entered them by column. Right back here, A, LSS, IQ, EST, those are entered into the matrix operation as columns, so I have to go by row. Why did I put true? Losing my mind, boys and girls. False. So again, I like to always kind of see. Now, I knew this was going to happen. What it has done, it has gone in, and even though we set gen recode as ones and zeros, you can see that it set it as ones and twos. And you know what? That's not what I want. So I'm going to go back gen recode.
Jeremy, did you something so disgusting?
And so as integer. So I'm going to just do gen.
I dare you.
Minus 1. And now gen is going to be ones and zeros is what I want. So I'm going to redesign my matrix. I knew that was going to happen. I just wanted to show you how stubborn that R can actually be. Sadie. She knows I am recording, so she wants to make a lot of noise. All right, guys. So now I get what I want. Ones and zeros in the final. Again, let me tell you what happens if you use twos and ones instead of zeros and ones. Everything will work out fine. The coefficients of the model will be the same, but the intercept will be different, and the interpretations, just a little different. But it's not a major deal. Guys, next thing I need to do is I need to design the Y matrix. So the the Y matrix is going to be my read. In number of rows is 30. In number of columns equal 1. And by row equal false. So check out your Y's and you'll see we have what we need. Well, first thing I'd want to do here is create my beta matrix. And remember, how do we do that? We take the inverse of x transpose times x. So in R, we do inverse by solve. So I need the transpose of x. Remember to multiply matrices correctly. We do percentage sign, multiplication, percentage sign. So right here, boys and girls, I have taken the inverse of the transpose of x times x. Now I need to take the transpose of x, and I need to multiply by y. So guys, our beta matrix will be this. So what we can do here is we can predict read by negative 28.50 plus 2.63 times LSS plus 0.49 times IQ plus 6.42, right? Yeah. EST minus 2.31, and I'm just going to call this gender, even though we used a gender recode. Now let's interpret. So the interpretation of, for example, IQ would be controlling for LSS, EST, and gender. The predicted read increases 0.49 units for each unit increase in IQ. Now, the interpretation of gender is a little different. Let me illustrate that for you. So still it starts out the same way. So we're going to be controlling for the other variables in the model. The predicted read. Now, what we have to do here is we have to think about what an increase in 1 unit means in terms of gender. Well, if you think about gender, gender was coded as 0 and 1, where 0 was female and 1 was male. So when we jump 1 unit in gender, we are moving from females to males. So because our coefficient is negative here, we would say that the predicted read for males, coded 1, is 2.31 units less than, hold on. The predicted read for males is 2.3 units less than for females. And remember, gang, they're coded as zeros. Now, let's say that we had decided to put in our model, instead of coding zeros for females and 1 for males, let's say we did it the other way. Well, what would happen here is our gender coefficient would have been positive, and the interpretation would be that the predicted read for females is 2.31 units more than what we predict for males. Now, guys, if we're going to, so let's predict the read for a male with LSS equals 6, and IQ equal 120, and EST equal 7. So what we would do I don't really feel like typing that again, so I'm going to paste it. Alright, so we would have our read equal, so LSS, this is 6, IQ is 120, and EST is equal to 7. Now, since we're looking at, for a male, we would code this at 1, and you can see by taking putting male in what we coded as 1, it's going to decrease what we get in the previous calculations by 2.31. If this person had been a female, we would have put in a 0. So in other words, controlling for everything else in the model, we could, if we put a 1 there, it would be decreasing by 2.31. It would be 2.31 less. Okay, let's just check our work. And we can clearly check our work by doing linear model, read LSS plus IQ plus EST plus gen recode. I think that's what I did, right? I've had so many different things with gen. No, just gen, my bad. Alright, when I do this and I get my model, you'll see that we get the same coefficients with R that we get using matrix methods. Now gang, the next thing we'd probably want to do is look at the standard errors of our coefficients, and remember the standard errors of our coefficients, we get the standard errors squared of our betas, examine the diagonals, and but anyway guys, an important part of this is the sum of squares. An important part of it actually is the mean square error, but we need the sum of squares error to get that. So I'm going to go ahead and calculate those, and it turns out these are calculated by taking the transpose of y times y minus the transpose of our beta matrix times transpose of our X matrix times our Y. Okay? So that's going to give us our sum of squares error, which is 8876.651. To calculate our mean square error, we're going to have to take this value and divide it by the degrees of freedom for the sum of squares. Now, depending on whether your mind works better with our predictors, a number of predictors being p minus 1, if that's the case, it's just going to be n minus p, which will be 30 minus, well, we have 4 predictors, so if 4 equals p minus 1, then p must be equal 5. Or if your mind works better with the predictors being equal to k, then the degrees of freedom are n minus k minus 1. So we have 4 predictors, minus 1. Long story short, we get the same thing. So guys, our mean square error here is going to be 355.06. All right, so let's do it. Let's create the standard errors for our betas. And actually, this is going to be squared. So we've always got to remember to take the square root of the values on the diagonal to get the standard errors for the coefficients. So guys, what we're going to need to do here is we need to take our mean square error times. In the past, we've had a hard time multiplying, but let's see what happens here. So I'm going to need the inverse of our transpose x times x. And we get this value, these values for the square of the standard errors for a beta. So for example, we can say that the standard error for gender is going to be the square root of 56.8854985. So the standard error for gender is going to be 7.542248. Now, since we've done our model, what we can do is we can do summary of our model. And, we can see that, again, using R, the functions in R, we can get our t-values of probabilities and so on and so forth. So just giving the illustration that the standard error for gender is 7.5422, which, of course, matches up with this. We can go on and we can do fitted values. We can actually come up with 3 sigils. We can go ahead and carry out the inference part, which I did before. I'm not going to do that because there's no difference in what we did with the quantitative predictors that we have with the non-quantitative predictors. Okay, now just to simplify things, I'm going to quit R here, and I don't want to save. But what I want to do now is I want to illustrate, a tougher model to come up with. Okay? So what I want to do here is I want to come up with model 2. And what I want to be able to do here is I want to predict read from LSS, quantitative, IQ, quantitative, EST, quantitative, school district, not quantitative, and it's categorical with more than 2 groups. Now, gang, this is what we get into. So we got a categorical variable. More than 2 groups. In fact, I think for this we have, I think the way it's set up, we had 4 groups. And I think this was District A, District B, down to District D. And I'm pretty sure these are coded 1, 2, 3, and 4. Now, guys, this is going to require us to create dummy variables. First of all, we will always need the number of groups minus 1 dummy variables. So for school district, we have 4 groups. So gang, we're going to need 3 dummy variables. I'm going to call these dummy 1, dummy 2, and dummy 3. Now, the next thing we need is we need what we call a reference group. The way this process is going to work is you are going to create 3 dummies. Again, we got 4 districts. But we're going to create a reference group, and I'm just going to let my reference group for this be District A. Which is coded 1. So dummy 1 is going to compare District B with District A. Dummy 2 is going to compare District C with District A. And dummy 3 is going to compare District D with District A. Now, how you choose your reference group depends usually on the either the clear intent or kind of a sub goal of your study. If you're doing a study on race, and for example, maybe you want to compare other races to Caucasian, maybe there are just more Caucasian students in your district, and you want to compare. There may be a justification to where you want to compare scores with Hispanic groups. It depends on the motivation of the study. If there is no motivation, we're just simply kind of looking at this in an exploratory fashion. I usually let my reference group be the group with the largest sample size. But let's say, for instance, some reason District A is setting the stage for reading scores, and we'd like to come in and use the district to actually predict reading scores for all districts. Now, limitation here, well, what if you, in the meantime, what if you wanted to compare District C with District D? Well, this model isn't going to allow you to do that. So if you want to do that, what you would have to do is you would have to come in with another model, set your reference group as, for example, C or D, and to go through your dummy coding appropriately. Now here's what's going to happen. Dummy 1, again, is going to compare School District B with School District A. And this is going to be comprised of zeros and ones. 0 is going to be not School District B. So if it's School District A, School District C, School District D, we're going to give it a 0. We're going to give it a 1 if it's School District B. Dummy number 2 is going to compare School District C with School District A. So we're going to give it a coding of 0 if we're not C. We're going to give it a coding of 1 if it is C. And it probably goes without saying, if anything in teaching goes without saying, I'm not sure, that dummy variable number 3 is going to compare D. So not D with D. Did I just repeat D? Whatever. I don't know. Sometimes I think I'm losing my mind here. So just be advised that dummy variable 2 is going to compare C and C. Not C will be 0 and C will be 1. Now, so again, gang, think about it. In our data set, we're going to create these new variables, dumvar1, dumvar2, and dumvar3. What are our entries going to look like for School District A? Well, D1 says if it's not School District B, we give it a 0. D2 says if it's not School District C, we give it a 0. D3 says if it's not School District D, we give it a 0. Okay? What's a School District B going to look like? Well, D1 says if it's not School District B, we give it a 0. If it is School District B, we give it a 1. And it follows that these will be 1s and 0s. For the same argument, these will be 0, 1, 0. And for the same argument, this is going to be 0, 0, 1. So take it from me, setting these up in Excel is going to be a lot easier than trying to set these up in R. So I'm going to try to illustrate that, if I don't end up beating one of my daughters beforehand. Oh, Daddy's recording. Let's be loud. That's why they make them cute, so you won't kill them. Wow, this thing's running super slow today. All right, gang. So now the first thing you would have to do is before running. I want to get these things centered up. Before running your analysis, it's going to help you using matrix methods. Now, it's not going to matter. I'm sorry. Using matrix method, it's not going to matter. Using R, it is going to matter. And what I'm talking about is we need to set up this first row with the comparison group that we want. Now, for example, let's say there was a justification where we wanted group number 4, district number 4, to be our comparison group. Then what I would probably do is I would come in here and copy and paste that and put it up here in row number 1. So you want the comparison group to be your first piece of data. Matrix methods doesn't matter. But in R, what it will do, it's got this slick feature, which doesn't happen in SPSS, where the first reference group the first group is by default set as your reference group. So gang, I'm going to set dumvar1, dumvar2, dumvar3. Okay, now what was dumb variable 1? Well, dumb variable 1 was we gave it zeros if it wasn't a 2, and we gave it a 1 if it was a 2. So what I'm going to do here is I'm going to use the if function. So I'm going to do if this equals 2, then I want it to get a 1, otherwise I want it to get a 0. Now I can do this slick fill down feature right here. And what it'll do, it'll go down and notice every place we've got a 2, that's what dumvar1 does, is it compares group 2, well, district 2 to district 1, which is our reference group. So every place I see a 2, it gets a 1. All right, I'm going to want to repeat that. Okay, so now what I want is if school district equals 3, then I want it to get a 1, otherwise I want it to get a 0. So fill down. Just check all these values right here that have 1. You can see that we're in school district 3. So that's going to allow the comparison from school district 3 to school district 1. The next one again equals if. So if school district is equal to 4, then I want a 1, otherwise I want a 0. All right, gang. Now, so you can see here we have a 4 and we have the vector 0, 0, 1, which is what we need. Notice every place we see a 0, 0, what do we have? Well, we've got school district 1, which would be what? Well, we can't compare District B with 1. We can't compare District C with 1. We can't compare District D with 1 because we are School District 1. So there's no comparison. That's the reference group. So there's going to be no dumb-var influence when we have the reference group. So guys, what I'm going to do now is I'm going to go to Save and go Continue. And my computer does not like CSV files. It acts like you're trying to do something crazy when you do this. All right, so I've gone in, created my dumb variables, and now I'm going to go into R. And really, I'm going to pretty much repeat what I did before. And I mean before with gender. So we'll set my working directory. I want to get my data. I want to attach my data. And I want to go data frame my data because this is something I've found helps us set up matrices slightly easier. Now, so if I go data, you'll see that I have my dumvar1, dumvar2, and dumvar3 included in my analysis. Now, what's the first thing I need to do? I need to see if dumvar1, dumvar2, and dumvar3 are set as factors. And actually I don't think it's even going to matter, but it's not. I'll tell you what, let's try it out. I know in the matrix methods it's not going to matter. Let's see if it makes a difference in the calculations using just the straight R. So, gang, let's go for it. So again, first thing I need to do, I always just kind of call it A. So repeat integer. Need ones to be repeated 30 times. And then I'm going to set my X. So matrix. I'm going to bind A. I want to do LSS, IQ, EST, and then I'm going to do dumvar1, dumvar2, and dumvar3. Number of rows needs to be 30. Number of columns needs to be, well, even though I just have one variable, school district, I've created 3 new variables that I have to treat as variables. dumvar1, dumvar2, dumvar3. So I have 1, 2, 3, 4, 5, 6, 7 columns. So I actually have 6 variables. And of course, by row is set up as false. So gang, you can see when I get this, it's just what I get. Okay? Now, I kind of wish I'd included gender in it, but if we wanted to, that would be fine. We could just go back in and add that. So, but nevertheless, let's just go with what we have. So I want matrix read. So in row is 30, in column equal 1, and by row equal false. So guys, let's do our beta matrix. We should be really good at this by now. All right, gang, so our beta matrix is going to be this one. Interesting. Okay. Now, let's do an interpretation of dumb-var 2. So we would say controlling for LSS, IQ, EST, District B to A comparison, and District D to A comparison. The predicted read in district. Now let's think about that. What we're doing here is we're looking at dumb-var 2, which is going to be this one right here. And how do we interpret that negative 12.2? Remember, we go from zeros to ones. So 0 is going to be district A, 1 is going to be district C. So when we put 1 in, our read is going to go down 12. So we're going to say that the predicted read in district C is 12.24 less than district A. So if you examine the signs of all the dummy variables, negative 6, negative 12, negative 3, it appears that district A has some good stuff going on. In comparison to the other district. It really would have been neat to actually go in and control for gender, but you hope there's not going to be any gender bias across school district. Now, let's go ahead and run this. I'm just really kind of curious to see, without setting up as a factor, whether we'll actually get the same model. So let's see what happens. Okay, well, wouldn't you know it? Yeah, R is pretty slick. This just doesn't happen in other statistical software packages that I've used. You have to account that dumb-var 1, dumb-var 2, and dumb-var 3 are actually that's pretty clever. I'm impressed. And you know what? I think what we could have done, since we set up our school district, I think this is probably where we're going to mess up. It's going to change. Let's run it where we just run school district. And I've been told, and I'll be perfectly candid and honest with you here, I've never tried this. So what if we just ran school district, not using matrix operations, and we just use school district? They tell me that it'll set that as the reference. And so I don't know, let's try it out. We may be onto something. So I'll run this as model 1. And I'm going to run a linear model and read with LSS plus IQ plus EST plus, now how was that? SCHD, okay. Okay, yeah. Now, here's a situation where it's treating my numbers in school district as counts, and we don't want that. So what I would have to do here is I would have to go so it's not a factor. So let's set it at 1. Now, We get it. Well, I am super duper duper impressed by that. So guys, I hope you understand that you see what's happened here. Matrix methods just crunches right through because it's using matrix multiplication. It's going to treat zeros and ones. Uh, uh, you know, as it should. But when we try to put school district in without making it a factor, and this is going to be a big deal when we get into logistic regression, but without making it a factor, it is treating these ones and twos and threes and fours not as factors, but as quantities. Well, they're not quantities. They're placeholders. We have categorical data. So when using this, you would have to run, change it over to a factor before using it in your model. It's still pretty slick that it comes in and takes your first one, so it automatically creates your dummy variables, which I don't know. You're not impressed, I'm sure, but I'm super duper duper impressed. Now, I suspect something's going to happen here. I don't know. Let's see what happens. So we've got our model here. I think I called it Model 2. So if I do a ANOVA LEM for Model 2, I'm going to get my partition of the sum of squares, mean squares, and so on and so forth. And let's see, that's not what I wanted. I wanted summary. Yeah, there we go. So when I come to the F statistics, so if I were to examine the ratio of the mean square regression over the mean square error, I would get 3.412 with degrees of freedom 6 and 23. Now, guys, let's make sure we understand why is degrees of freedom for the regression 6. Well, because we have 6 predictors. Why is the degrees of freedom for the error term 23? Well, 30 minus 6 minus 1 gives us 23. Nevertheless, our p-value is 0.014. Remember what the F statistic tests? It tests the the null hypothesis would be that beta 0, beta 1, beta 2, beta 3, beta sub k, or beta sub p minus 1 are all equal to 0. We reject that, concluding that at least one of the betas is not equal to 0. And it turns out that EST appears to be the most the only statistically significant predictor when controlling for the other variables in the model of Reed. So kind of interesting there that IQ, and guys, I didn't make this data set up. Controlling for IQ, the kid's estimated reading level is actually the best predictor of their actual reading level, when controlling for the other variables. Now, guys, sometimes we run into a dilemma. And I don't know whether I'm going to have time to do the dilemma or not. I'm at 48 minutes, so yeah, I was getting ready to get on a tangent with you, so and it was going to get ugly. But I'm not. I kept you guys